I'm Stephane Maldini, and I'm the lead for the project Reactor. I hope you know something about Reactor and project Reactor in general, because this is going to be an update on the latest new and worthy things we have released with the latest version codename Californium. Just raise your hand. Who has actually used Reactor or is using Reactor right now? Right, so roughly 40% of the room. It's going to be interesting. Who has used RxJava or is using RxJava? Right, okay, so quite a lot of people as well. All right, so it's going to be interesting for people not knowing reactive programming or Reactor in general. And I have a link to a few sessions, unfortunately happening after this one tomorrow. I will be introducing you to reactive programming in more details. This one will focus on the few new features, but I will try to get things, keep things as simple as possible. So why Californium? In Reactor, you will see we use a version scheme for our release train based on the periodic table of elements, and Californium is the third one. Because it's the letter C. We had before aluminum and bismuth. And this is the third one. It's the third year of this release trains. We started doing that in end of 2016, I think, or yeah, something like that. And that's the third version. No one knows really about this element. I don't know anything about this element, but I really like the name. But in fact, every time I think about this element, I really think about California. And this is my new home since I moved from London 2 years ago, no, 1.5 years ago. And I kind of like the parallel as well. We spent the last 9 months developing this version, and that roughly corresponds to the timeline we used for me to move and for this version to get out. So we just released last week. Just in time for the latest version of the Spring ecosystem. And what does it mean? It's a release train, so it ships with a few versions. It ships with the latest update for Reactor Core. It's the core foundation for reactive programming we deliver in the project Reactor. So that's where you will find everything functional programming. So to say, how to compose asynchronous sequences like in RxJava, you will find things like flux and mono, and so that's where it lives. And there are new additions in this project I'm going to talk about. There is an extra pet project we call Reactor Addons, where things we don't feel like ready to be in core or things we feel just totally fine separately from core live. You will find adapters, for instance, to run a reactor on top of AK, for instance. That's one thing. You will find extra utilities to implement retry and retry patterns for flows that might have errors as well. So it's pretty interesting for things we don't feel like ready or just not necessarily in core. And the last but not the least, a Reactor Netty, which is a simple bridge to the famous Netty framework. And when I say bridge, what we give in addition to Netty is simply a way to translate the specification reactive streams, the specification about reactive programming we implement, into Netty. And so this is a simple bridge. We provide a simple API on top of this translation, but we really a low-level library. And mostly Reactor Netty is used in drivers. You will find it used directly by things like something like Foundry Java driver, Java client, the latest RabbitMQ Java driver. So it's really a low-level library, but you don't want to do all this translation from reactive flows into Netty yourself, so it's already there. We'll see a few examples of that in this presentation. It's now shipping with Spring Framework 5.1, locally released last week. And of course, it's soon to be in Spring Boot 2.1. What we're going to start with now is Reactor 3.2 and the latest editions in Reactor 3.2. The first thing we have experimented with, and we will collect feedback during the 3.2 lifecycle, so 3.2.1, 3.2.3, 2, sorry, and 3, etc., is the support for Micrometer. And basically what we do now, we have a new operation you can use in fluxes and mono called metric. And combined with other operation we have called name and tag, you can give a context, a name, and monitor any flux or any mono you want in a reactive application, whether it's Spring or not Spring. It's pretty powerful. And if you don't have Micrometer on your class path, it's not going to work. So it's really depending on Micrometer. It's not forcing the dependencies, so it's just detecting if it's there or not. And if it's there, it's going to give you metrics. So how does it look like? We have the use here of the name operation, which is not really an operation. It's something to give a name, an arbitrary name to a flux. For people who have never seen really before a flux previously, this is pretty similar to what you might see with Java 8 Stream, for instance, except this API is specifically designed to support reactive programming, so things can take time. And as you can see here, I use an operation called delay, and I had like 100 milliseconds delay for every item I emit. Flux range is just a kind of for each, translated in reactive programming and Flux that gives just the API like that. So I give a name to this sequence, and a bit after, I declare the operation metric. And because I do that, and I have a name, I will have this flux exported to Micrometer. So we'll see in a second how it looks like. The thing is, with the metric operator, we have an opinion on things we want to monitor. And obviously, we will take feedbacks if you have some. Right now, we timing the delays between each or next element. So every time there is a data, how much time it takes to arrive, how much time an entire sequence takes as well. So if you have a range of 100 elements, how much time it takes to go from 1 to 100. Obviously, that's just numbers, but imagine if it's like doing web client calls using Spring, and you have 100 of web client calls, that will just work the same. You call, time, how much time it takes to do all these calls. We can tag, so it's pretty interesting because Micrometer, if you're aware of the library, is all about tagging and giving dimensions to things you want to monitor, and we give this as a feature in Reactor as well. And an interesting part as well, we monitor if you start implementing reactive streams yourself. The specification, we depend on as a Reactor project. Sometimes developers try to implement the reactive stream specification by themselves. We shouldn't do that. Every time, try to use Reactor. Worst case, use RxJava. That's all friends, and don't use the rest. No, I'm kidding. Obviously, it's important that you're not trying to implement the publisher specification. And I think every vendor will, or library supporter will tell you that. So if you do, metrics will be able to, or will try to detect malformed or wrong use of reactive stream specification. But, shouldn't occur if you stay, within the safe world of Reactor at least. Obviously, Micrometer is cool. We detect it if it's in a class path, but it works just even easily if it's very easy to use if you use Spring Boot, like 90% of our developers. And because you can use Micrometer with any registry you want, here as an example I use Prometheus. You can export natively to everything Micrometer supports. So Atlas, Prometheus, and other backend for metrics. In this example, I use Prometheus, so you will see if you use the actuator and go to /Prometheus, you will see this kind of trace. And this can be consumed by a third-party UI, console UI, the most famous one being, in my opinion, Grafana. And if you consume this kind of metrics from Grafana, you can build easily dashboards like that, basically. So really what we intend to give to our user is how fast you produce data and how fast you consume data. It's basically the two key metrics. Just because when you start adopting reactive programming, you see, in general, better efficiency. And as a side effect or a byproduct, sometimes you see better performances, but you want to qualify that. So it's cool to have a way to qualify that and start monitoring how fast you are producing now and how fast you can consume data. It's pretty important, at least to justify the cost of transforming your application to a reactive application. The other thing we have unique to Reactor is what we call context. A problem we have in general in the reactive programming is how do we translate something like thread local? Thread local doesn't really have an alternative in general in reactive programming. Everyone has kind of an alternative. Well, not everyone, but a limited alternative. We have one unique to Reactor, and that means we give a way to associate with a flux or a mono all the way kind of attributes or metadata you can consume at any point in the stream. So what's a context? It's just a kind of map. Every time you put something in it, you get a new context. It's a copy on immutable copy on write map. And every time you subscribe, this context is getting propagated from the very end to the very beginning, so from the consuming side to the producing side. It looks like that when you start using it. So the second line will be how you inject data in the context, or how would you initialize the context if you want to initialize the context. And the first line, which is mono-subscriber context, is how you can retrieve this context and emit something. And by the way, I'm using, for people who are not familiar with Reactor, I'm using something called step verifier, which is a way to test reactive flows as well. Instead of having assert, like in assert, in JUnit, where you would start using assert J, for instance, and sequentially assert things, we have something called step verifier, where you register expectation about something that might happen in the future. And that's exactly what this step verifier does. And that means you don't have to block every time to verify your flow. You just block at the end when you start saying verify complete. So it's pretty interesting. And so the context is unique to Reactor, and the thing we are quite proud about with the context is it does propagate to inner flows. And that means sometimes from a given data, you are going to do a nested asynchronous call, what we call flat map. And from inside this flow, you can also access this contextual information, which you can totally not do with thread local. And because we have this option, we have started implementing a few things. And the few things we have started working on already by 3.2 are Spring Security, Spring Cloud Sleuth, Spring Data with the transactional support. Everything you can think about that already is using in Spring today, thread local, have or is working on an alternative with the context. And that's kind of cool. Specifically for 3.2, we do use the context now for 2 new operations, and I'm going to go through them just now. The first one is called DoOnDiscard. It's a new operation we have introduced in Reactor 3.2, and its purpose is really to reroute upstream discarded items. So what's a discarded item? It can be something you filter or something that might just disappear from the flow because it has been canceled or there was an error. It's really useful. In general, if you start building pipelines and if you start building a specifically pipeline with use of resources, it's very, very useful. In Netty, we have something called pooled byte buffers. And these things are very complicated to manipulate. And specifically, when you're done manipulating them, you have to call something called release every time at the end. And doing that is quite a challenge if you do that, with any reactive library. In Reactor, with this new operation, what we have introduced with the DoOnDiscard is just a callback like any other operation. And with this callback we call DoOnDiscard, we can capture anything that might be lost or swallowed by the flow. In this case, every even number are going to, every odd number are going to be filtered. And what happens if they are filtered? They just disappear in the void. In that case, with DoOnDiscard, we do actually capture all these numbers which we have filtered. So we have a way to reroute these numbers to something. It's not like they disappear just like that. And the other interesting aspect of that is sometimes you use Reactor to do collection of data. And for instance, for this operation, you might use collect list. But at some point, you might, during the reactive flow, you might just say, I'm not interested anymore, I will cancel. Before it's actually completed, before you have collected everything, you might cancel, or you might see an error going through your stream. And what happens before 3.2 is we just drop the data, and it's done, it's just disappearing. And now with this DoOnDiscard, we can also redirect the data to actually do something with the DoOnDiscard callback. And it's pretty cool because we also flatten the structure. So a collect list will collect everything in a collection, in a list. But with DoOnDiscard, you react basically for each element that might have been dropped within the list. So it's A, B, and C. You will see with this example. It's pretty powerful. And obviously, because we have testing support, we have added everything you need to do verification on discarded elements. So we have this keyword like as discarded and as exactly discarded. All this kind of thing you can use from the step verifier facilities to see what has been really discarded by the flow. I don't even use DoOnDiscard in this flow. It's just the step verifier registering itself as a DoOnDiscard. So it was quite a big task to do this, and we might not support everything you want to actually, or you expect to see the support for. In the documentation, in the Java documentation, Flux.html, if you go to the project site, you will see every operation we have support for this new DoOnDiscard will be marked with an extra onDiscard support, just after returns and parameters in the Java doc. It's pretty interesting to see which operation is supporting this discarding callback. It's also not guaranteeing the exactly once invocation. That means sometimes a same data can go through the same callback more than once for specific operation, unfortunately, not for everything. In fact, it makes sense when you see the kind of operation that just does that, overlapping buffer and overlapping windows. You will, if you cancel multiple overlapping windows that are currently alive, the same data might be alive in multiple flow, basically. So it will be invoking at the end multiple times the same callback. So you will have to use your deduplication if you need to do so. In general, it's pretty easy to do, but we don't take this assumption ourselves. Then the other big operation we have is onErrorContinue. You will see it's similar deal than onDiscard support, except here we will try to absorb errors you will think not necessarily fatal for your flow. Because right now Reactor will stop your flow as soon as it faces an error. That's because we implement the specification. But we can go beyond the specification. Especially, it's pretty important for all messaging use cases like Spring integration, for instance, or Spring Cloud Stream. These kind of use cases where you have one Flux alive for the entire time of the application lifecycle, and you don't create like webflux a mono every time there is a request. It's pretty important that this Flux stays live. And to do so, we have this onErrorContinue operation you can use in Flux. And basically, what happens here, I will emit just a 0 and 1, but just after that, I have an arithmetic exception because I divide 1 by 0. just as the first element. But this is a kind of exception I don't necessarily want to, I don't want to be fatal for the flow, so I will just absorb this exception and react to it by using this onErrorContinue. I would even have access to the original data. And what this thing is going to print, there are some log because I used the log operation as well, but this thing is going to print exactly the unsubscribe, the request, and the divided by 0 error message, which I printed in the callback. And then continue, you see on X1. If I didn't use onErrorContinue, I would just see on error, and that's it. So my data, my flow is done, and I can't use it anymore. So this thing just prevents your stream to stop working at the first error. So the other interesting thing, because we use context, is that it's working obviously for nested flow, and that's why everything connects. The context support we have in Reactor is pretty important because thanks to that we can implement all of these things. Otherwise, we wouldn't have any option to implement this kind of meta strategies for all the flow, and that works even for nested flow like this flat map is doing, and that's pretty cool. The thing is for onErrorContinue, same deal. It's pretty orthogonal to a lot of operation which implement it, obviously, but some might not implement it, and you can detect who's implementing and who's not implementing this resuming mode by looking at the Java doc. Another keyword, error mode support. And the limitation I will see as well with the onErrorContinue will be that it works well for failure during the processing of the data, but at the start of the sequence or at the end, we cannot really prevent the flow from stopping. It's really fatal at this point. There is nothing we can recover from. It's impacting the way the flow is working as well. If we drop data, because the flow is continuing, basically, we just reroute the error, and then the next data arrives. That means we need to account for the missing data. We need to ask for one more missing data to the producer. So it's taking it's a kind of an impacting effect on the flow. It's in theory not really impacting concretely, but it's something we need to be aware of. And there is no use case really for mono, because mono is only a success or not a success. So there is nothing to recover. You can already use operation like retry to do that. And at the end, I would say the retry backoff is also a very important addition. So we have a retry operation already, but this new one is pretty pragmatic because it's already implementing things everyone is using all the time. Randomized exponential timeout. So when you retry, you see basically in this example, when you retry, you don't want necessarily to retry 3 times and that's it. You want to give an exponential timeout backoff, and you want to retry not immediately, but like 100 milliseconds later. And you might give even a maximum of time, so retry backoff can take a maximum of time you want to retry it to. And also, you don't want to do exactly 100 milliseconds, because that's the way you have massive retry, timeout, all synchronized issues. So we will randomize the time. It's not going to be 100 milliseconds, but it's going to be more or less 100 milliseconds, maybe 80, maybe 120. You can tune that, obviously. But that means every application using, every similar application will be using different timeout. This is a JITA we introduce for this kind of retry scenarios. So it's pretty powerful. Don't forget, in Reactor we have we can use the virtual time, so you don't have to wait actually 2 seconds for the test to complete. With virtual time, you can say, okay, everything now will use the time I want, and if I decide I want to move forward the time of 2 seconds or 1 minute, I will do that, and all the internal clock of the library are going to be aligned with this time. If you don't do that, you have tests waiting forever because they use real time, and you don't want to do that. So there's a kind of random time we can get between retries. So you see it's exponential, it's increasing, but also it's not exactly every 100 milliseconds or a multiple of 100 milliseconds. And yeah, in the latest edition, we also have usingWhen, which you might see demonstrated tomorrow in the Spring Data sessions. With usingWhen, basically, we can have a full control of the lifecycle of a resource, and obviously that's very useful for transaction. So it's a new operation we have introduced to Flux. It's basically giving you a callback for everything when you start a sequence, when you stop a sequence. So here we call back when it starts to commit, when it stops to commit. When it starts, we call back to the from call label. And the interesting part is when there is an error, we call the alternative flux, which is here the rollback. And it's not only for the error we do that, we can also do that for the cancellation. So if you add an extra argument to this new usingWhen method, you can also call something when the flow has been canceled, which is pretty important. I'm not going to go over everything we have in Reactor now, but it's important to see the well-prepared release notes. We do that, we try to do that for every Reactor Core version. You have a full list of big changes and less big changes as well. And we have things still in the oven. We will try to provide in the next major version. So we think about a full refactor of the processor API. But we decided it was just too impacting just for now. Other things we are doing right now, we have a pull request from a community member, and we are converting every images you've seen, the marble diagrams. Right now they're using OmniGraffle. It's a proprietary tool to create these kind of diagrams. And we are converting them to SVG so everyone can edit and play with them. We are adding the metrics we've seen earlier to schedulers, and we are tuning a few other methods, in the API like FluxSync, TryNext. Another big thing I think you're going to see very soon is the website improvements. We want to refactor the site and present it better. It's been a long time we haven't touched the general presentation, so we're thinking about some improvements here. You might learn way more about how reactive programming works in general and what's the flux, basically, with the presentation from Simon tomorrow at 3:20. And for Reactor Netty, I'm not going to dive into Reactor Netty very precisely because there is a full session about that tomorrow as well from Violeta. I will detail after that. The only thing you have to understand about the latest update of Reactor Netty 0.8 is a change in the API, and that's something you have to keep in mind. Reactor Netty is 0. something. That means we are not confident yet with the API, and if you're using it directly instead of using webflux, you are a bit on your own, basically, because you are at the mercy of our API changes. And they might happen. We did a big kind of refactor right now with 0.8. Spring shields you from this kind of thing. It's obviously very low level and very direct and much more efficient in that way than using a layer on top like Spring. But if you do that, you're signing for an interesting adventure. So one big thing in the Reactor Netty that you will discover tomorrow with Violeta is we changed the API to really look like what you see with Spring, except it's just low level and we don't do a lot of things. But you see it's a kind of builder API. We see that everywhere now. And one thing I like about this new API is it merged, before we had the concept of configuration, now it's merged into one thing, one builder API. You don't have a lot of nesting. When you start doing functional programming, you see a lot of tab indentation or space indentation because you open a closure and inside you do something and you open a closure. This API has one goal first was to remove the nested level to 1. And with the previous version, we had a lot of this nesting. So we removed that. We merged the API, the option configuration with the builder itself. So it's only one thing, one top-level entry type you're going to use. If you want to use HTTP client, just use HTTP client. Yeah, you have nothing else to use, like a configuration factory or whatsoever. It's all starting with the HTTP client, and that's it. And the thing is, we are also use that time to make the API a bit more elegant with the basic decoding stuff. So you want to see the presentation from Violetta tomorrow, even if I'm in competition with Violetta on this one. But it's a pretty important one if you want to use Reactor Netty directly, if you are a driver, if you don't need all the smart stuff Spring is adding on top of Reactor Netty in Spring Webflux, you can use Reactor Netty directly and benefit from it. So that's pretty much it. We are done with the version C Californium. Next, we don't even know what name we will give to Reactor. Release train. You can vote if you want, you can decide. Unfortunately, the letter D has not a lot of elements. They are all boring, basically. But yeah, we have to decide between the three of these. And that's pretty much it. So thank you. And yeah, if you have any question, do we have time for a quick question or two? Any question? Yep. Yeah. Mm-hmm. So the question was, is it possible to use the flux onErrorContinue for an entire stream? It is for an entire stream by default. It's catching everything in the flux. So it's not like the previous direct operation. It's everything in a flux. It's not only one thing. Yeah. Any other thing? Or we can take it offline? Yeah? Okay, I'll take offline. Thank you.